We're going to start off 4.4a with a little bit of an investigation. We're going to try to take the approximate values from the unit circle and find their exact values. So let's go ahead and take a look at this. The exact values of trig functions, if theta is 45 degrees, how many pieces of pi is that, or how many radians? Remember a good shortcut? Pi is the same as 180 degrees. If you just put 45 in here. If you simplify this fraction, well, you're going to realize it's the same as pi over 4. Now, we know the approximate values if we were to go on the unit circle for pi over 4 or 45 degrees right here is going to be 0.707 and 0.707. But we need to get away from approximate and get to exact. So to do that, we have to be somewhat creative. Keep in mind, if we're moving 45 degrees, if this angle right here is 45 degrees and we're embedded in a right triangle, do I know this other angle up here? Sure, it has to be by default another 45 degree angle. So we know here we have two 45 degree angles. So this triangle is really an isosceles triangle where these two legs here have to be the same measurement. So what I'm going to do, since I know that this first movement here is our x movement, this here is the y movement, I'm going to call it x though too, because this is an isosceles triangle, so they're the same. Now I know that the hypotenuse, because it's a unit circle, is 1. So can I solve for the exact value of x? Sure. We'll use the Pythagorean Theorem. A squared plus b squared equals c squared, where c is the hypotenuse. So I'm just going to put in, for my a, I'll call it the x squared. For the b, I'll do the second x and square it. And then the c is going to be 1 squared. Well, x squared plus x squared is 2x squared. 1 squared is 1. To solve algebraically, divide by 2. So x squared is 1/2. To get rid of the squared, take the square root of both sides. That's going to allow me to break up the square root, do the square root of 1 over the square root of 2. It's going to be 1 over the square root of 2. Now you can't have a square root on the bottom of a fraction. You must rationalize the denominator. The only way to get rid of that is to multiply by the square root of 2 on the bottom and on the top. It becomes the square root of 2 over the square root of 4, which really just simplifies to the square root of 2 over 2. So what we now know is on the unit circle, the approximate number of 0.707 is exactly equal to the square root of 2 over 2. We need that value because we're going to go to the approximate circle and change everything to these exact values. Okay, let's do that same analysis but with 30 degrees. 30 degrees, how many radians is that? If you can remember, it is going to be pi over 6. And let's investigate this one. Now, we know if this is a 30 degree movement here, again, we have the 90 degrees here, so this has to be 60. So we have a 30-60 triangle. Now, one of the things we know about this movement, the right movement here was 0.866, the up was 0.5. Well, I actually know what the up is. 0.5 is exactly the fraction 1/2. So we technically do have part of the exact value there. So I have this value for this side, and I have this value for that side as the exact. How can I find what this x movement is right here? Again, the Pythagorean Theorem is going to work very well here. So let's set it up. Again, we know that c has to be 1. I'll call a is just the x side, so x squared, plus we're going to do 1/2 squared equals 1 squared. We simplify. 1/2 squared is 1/2 times 1/2, or 1/4. And that's 1. Let's subtract 1/4 from both sides. 1 minus 1/4 is going to be 3/4. Come on in, let's take the square root to get rid of the squaring. So x is equal to the square root of 3 over the square root of 4. This simplifies to the square root of 3 over 2. So here's what we know. The decimal 0.5 we're now going to call the fraction 1/2. The decimal 0.866 we're now going to call the square root of 3 over 2. So we can now go to our approximate unit circle, replace every approximation with an exact value. Now in the table format, let me just show you a few of them. Again, we did pi over 4 and 45 degrees. These approximate values are now becoming exact as square root of 2 over 2, square root of 2 over 2. We also looked at pi over 6 or 30 degrees. We know these values now stand for the square root of 3 over 2 and 1/2. By the way, right here, 1 and 0 are already exact, so we're good on that. So is 0 and 1. We can just wrap up this here. This is 1/2 and the square root of 3 over 2. So let's go to our circle and adjust it. Like the activity we did before with approximations, let's go in and identify the 4 key items: the degrees, the radians, and now the exact ordered pair. So 1, 0 stays there. This is the square root of 3 over 2 and 1/2. Square root of 2 over 2, square root of 2 over 2. Here we have 1/2 and the square root of 3 over 2. And then we wrap up here with 0, 1. So we see here the complete movements within one of the quadrants. In doing the other quadrants, remember they're all connected by the pi values. All of our pi over 6s are going to have the exact same numerical values but different signs. Same with the pi over 4s and pi over 3s. So doing that, our new unit circle will look like this. And the values are as you see them here. This is the exact unit circle, and we're going to use this now going forward and not use the approximate one anymore. Do know everyone is going to be tested, and it'll be required to know everything about quadrant 1. You're going to have to list for all 5 of these ordered pair components the degree, the radian, and then the ordered pair that actually gets you there. So quadrant 1 is required. The entire unit circle is extra credit. If you can memorize the entire unit circle and state the degrees, radians, and the cosine and sine value for every single spot on here that's labeled with a dot, will be extra credit.